are working on a pulse power machine that is this setup, and we have a chamber where we have loads, usually wire loads, either X benches or wire arrays. And what we do is basically we drive current through these small wires to get high densities and temperatures. So for us, it's very important to know the size of our sources. For that, we use the MCP that we have over here. So basically, we're looking at our source size or plasma, and we use an imaging system with pinholes that will tell us how big it is, and it will also show us what the plasma looks like, the distribution by the gain. Would you like me to tell you about the other diagnostics? We also look at density through optical system. So that would complement what we see for the MCP. We will also see how the density of the plasma varies along the wires, either if it's an X bench or a wire array. And we also have pin diodes, which will tell us how many sources we have, and that will complement whatever we see in our image. Because if you have 2-3 sources, then we can explain what image we're looking at here. So the energy of our sources that we get would usually go between very low energies of 100 eV, but we can go up to, say, 8-10 kilo electron volts. So that's the energy of our sources, and according to filters, we can distinguish which energy ranges we're looking at. Our source sizes are usually between 100 and 200 microns, depending on what load we have. So that's what we're looking at with our pinhole. Densities could be 10 to the 15, 18 centimeters cubed, and temperatures of maybe 100 eV for the plasma itself. Most dense areas would be more energetic, of course. So usually our hotspots or our X-ray bursts that we want to measure would have a full wavepath maximum of 7.5 nanoseconds, which is why having an MCP would help us resolve those, because we can track down where maximum emission happens. At the MCP, we can use anywhere from 5 nanosecond time integration to, I believe, 15. We are using it now at 10, so we can track down before the hotspot formation, to the formation, and then a little bit after, so we can see how it actually happens as we trace down our load. So we can take a time measurement and have an